Hey, welcome back. If you happened to watch my 48 Hours of Ruckus video, then you probably saw that T2 broke down. It died on me when I coasted to a stop or came to a stop, and then I could not get it restarted again, so I ended up getting a ride home in the back of a truck. I haven't touched it since then. That was on Saturday, and it is now Wednesday. All I can tell you is that it still won't start, so I've really got to figure out what's going on with it. I'm going to begin my troubleshooting with a spark test using this adjustable gap spark tester first, largely because spark is the easiest, quickest thing that you can check. I'm not getting anything there. It really should be able to jump that, but I'm going to go ahead and screw it in a little bit more and see if it has a little bit weaker spark at least. I got no spark at all, and I even tried adjusting this tester down to the 10 kilovolt range or a little lower, which is a very small gap between there. And when I first installed this MVT ignition system, it would consistently jump a 25 kilovolt gap, which is up here somewhere. And now I can't even jump a 1/4 inch gap. So definitely a problem. Now I know I'm going to have to do some electrical troubleshooting on the ignition system, so I've gone ahead and got the scooter up on the workbench. I took the seat off, and I've got my wires cut free so they're not all secured to the frame. I want to try to check the output from the stator related to the ignition system, so not the charging and lighting, but what actually would power up the CDI and allow it to trigger and send a spark. So this CDI, or this stator, actually has 2 wires coming out of it related to the ignition, and that is a red and black here, a red wire with a black stripe, and then there is a yellow and green wire. And the yellow and green appears to be just a ground. The red wire with a black stripe is the exciter output, so that is what charges up the CDI and allows it to make a spark. Normally what I'm used to is that you'd have a wire coming from the exciter coil, and then you'd also have a pickup wire or a trigger wire that tells the CDI when to fire. But in this case it doesn't have a dedicated pickup or trigger wire. I assume it just uses the output from the exciter coil to tell it when it needs to fire. So I'm going to try to test this wire first. I'll disconnect this red and black wire from the CDI and the rest of the harness, and I want to make sure that I've got the end that goes toward the stator, not the one that goes into the CDI or the harness, but the one that goes to the stator. So just trace the wires and you'll be able to easily tell which one goes toward the stator. And this is the one that I want to use the red probe, the positive probe from a multimeter on, and you've got to get that in there and make sure it makes a solid connection with the actual metal of the terminal. I'm using different terminals than this came with, so yours may be different than mine, but whatever you've got, just make sure you get a good connection of the metal bit of the probe to the actual metal inside of the terminal. I put a little bit of electrical tape on mine just to make sure it doesn't come loose while I'm messing with the other connections and trying to do the test. And now I'll take the negative probe and attach that to a good ground. In this case I'm just using an alligator clip, putting it right on my ground to the engine. Now I'm going to turn my multimeter on and to volts. If yours has AC and DC voltage settings, set it to AC volts. I'm going to change my range just to make it easier for me to read. Also turn my backlight on. And then I want to switch to the max setting. Not all multimeters have a max function, but if yours does, use that. That will record the maximum voltage that it sees rather than you having to watch and try to note the maximum voltage that you see when you're cranking the engine over. Now I'm going to hop up here and see if I can work the Kickstarter. You can use an electric start, but I'm guessing most of you using a race ignition probably don't have an electric start. So give it some kicks over and we'll see what it reads on there. You can see it maxed out at 50 volts while kickstarting. Now, if you don't have any specs, that doesn't necessarily mean anything to you. Luckily, when I first installed the MVT ignition, I actually did do these tests to make sure that if I ever had to troubleshoot it down the road, I would have some specs. And what I found was that when I cranked it over with a drill slowly, at the time I didn't have the CVT on, I couldn't kickstart it, but slowly to replicate about where I'd be with a Kickstarter, I got 25 to 50 volts there, so that's looking pretty good. And if I turned it over faster, the voltage would go up. My max voltage with the drill was 66.5, but at any rate, that looks pretty good. It looks like I am getting the output from the stator that I should. Since that checked out, I went ahead and reconnected the red and black wire, and now I'm going to disconnect the other wire, the green wire with a yellow stripe. Now I'm going to turn my meter on to the ohms or resistance or continuity checker. And just turn my backlight on. So you should see the ohm symbol on your meter if you're in the right spot, or maybe that symbol there. In this case, I'm going to leave it on the continuity checker for now. So basically what happens there is it will give me an audible alert, a beep, whenever both probes are connected to something with continuity. So right now my negative probe, the black probe, is connected to a ground. So if I touch this red probe to a ground, I should hear a beep. Just like that. And I'll also see a reading on here. Now I've still got the negative probe attached to a ground, and then I'm going to check both ends of this connector for continuity with ground by attaching my red probe to those. You can hear it's got continuity, and it looks like 0.1 ohms, so good connection, or 0.0 now. And then I'll check the other end. And again, I've got continuity there and a low reading. If you don't have the continuity checker, you can just set your meter to check for resistance, and you should see your resistance very close to 0 when you connect a good ground to either side of the ground wire coming from or to your stator. Since the output on my stator is basically what I'd expect, I've got both wires reconnected now. And I'm going to go ahead and put all of the specs that I have for the lighting system as well up here on the screen, just in case it's useful for someone as a reference. The next step for me is going to be trying to test the ignition coil. So I will tell you that if you check any service manuals or anything like that, you'll normally find that the procedure for checking an ignition coil involves removing it from the frame and removing all connections. In this case, I've got the spark plug wire removed from the spark plug, and I'm going to go ahead and pull the wire off of the positive terminal here. Other than that, as long as my readings are roughly in the specs that I expect, I'm not going to remove it from the frame. If the readings are off, then I probably will remove it from the frame and recheck it. There are two types of resistance when you're trying to check an ignition coil. There's primary and secondary. So primary resistance is the resistance between ignition coil positive and the base or the ground of the coil, and secondary is between the base or the ground of the coil as well, but that one is between there and the positive end of the spark plug. So you can either check the spark plug cap, the metal inside of there, or you can actually remove the wire. If you want to check just the coil by itself, you can remove the wire and check directly on the terminal where the spark plug wire connects. I'm going to go ahead and turn my meter on to resistance. This time I don't want to measure continuity, I actually want to see the resistance figure. And if you have an auto ranging meter like this, it should automatically pick up whatever the resistance is and switch as needed. If not, you're going to need a setting for the first check that will measure somewhere between 0 and 10 ohms, something like that. Checking primary resistance first, so I'm going to take the positive probe and touch that to the positive coil terminal. Then I'll take the negative probe and touch that to the base of the ignition coil. Let's see where that ends up. So it looks like about 0.5 or a half ohm. Now I want to check the secondary resistance. So I'm going to take the red probe and press it against the metal inside of my spark plug cap here. And then once again, the ground, the negative probe, will go to the same position to the base of the ground of the coil. And now it looks like I've got 10.94 kilo ohms. Unfortunately, I don't have any specs for this MVT ignition coil. I didn't check it, it looks like, out of the box, and MVT doesn't publish any specs that I've seen. But luckily I have checked quite a few scooter ignition coils in the past, and normally for primary resistance I see somewhere between 1/2 and 1 ohm, so this is in spec there. And for secondary resistance, most commonly I've seen 1,000 to 11,000 ohms, so again, in spec there. If you are off spec with either one of those by far, then I would again suggest to remove this coil from the scooter, totally disconnect it from everything, and recheck. In my case, it seems to be okay, but I think what I'm going to do just to be certain is I'm going to go ahead and check my coil wire or my plug wire and cap just to make sure that those aren't out of spec anywhere. This is just a thread-on setup, so all I've got to do is basically twist and unscrew the wire from the coil, and then I should be able to remove it. Since I'm this far, let me just show you. This is the same exact setup that I had before for the multimeter when I was checking the coil. I'm going to go ahead and check the secondary resistance again, this time without the plug wire attached. So negative probe to the ground or the base of the coil, and positive probe right to that screw where the spark plug wire would attach. And then I've got 6.25 thousand ohms. So that's about what I'd expect, considering I have roughly a 5,000 ohm resistance, I would assume, in the wire, but I'm going to go ahead and check that too. Once again, the meter is set up to read resistance. I've got the entire assembly here with the wire and the cap on it. I'm going to start that way. Doesn't matter which probe goes where, so one probe goes on one end of the wire. These are solid coil wires, so just make sure you get the probe into the actual metal there on the inside of the wire, the very center. And then get the other probe onto the metal in your spark plug cap, see what you got. So just a little shy of 5,000 ohms. This should be a 5,000 ohm resistor cap, a 5K resistor cap. So that's about right, but we can be even more sure and go ahead and remove the wire from the cap. Again, it's just a twist off style. You unscrew it basically and pull it out. So now I can try the wire, just again probing both ends of the wire to see what the wire itself has. Hang on, I don't think I got a good connection there. Let's retry that. So basically 0 ohms. And now the cap, again, this is supposed to be a 5K resistor cap, so it should have about 5,000 ohms of resistance. I'll take this rubber end off to make it a little easier to see. There's a little screw under there. So one probe goes on that screw, the metal section. Other probe, metal under the other end there. And yeah, you can see it's just a little shy of 5,000 ohms, so pretty much right where it should be. And hopefully you could see, you can actually look at the cap itself and see it is marked 5K ohms, so 5,000 ohms. With the stator and the ignition coil both checking out, I would guess that it's the CDI. But unfortunately, the CDI is not an easy thing to check. My understanding of most CDIs is that you actually need a special CDI tester in order to check those out. I don't have that, so normally what I would do is to unplug the CDI and plug in a known good one, or at least a new one, and see if I got spark then. Unfortunately, I don't have a spare for this MVT CDI, and they're pretty expensive, so it's not the kind of thing that I would normally keep 2 or 3 around. Since I can't test the CDI itself, and I don't have another one around, and I've got to wait to get one, I'm going to go ahead and do another test to see if other common failures are present. So another 2 common failures of the ignition system are either the kill switch or the ignition switch. In this case, this is a ground to kill type of system. That means you have to apply a ground to the CDI in order to disable the spark. So if the kill switch were faulty and it applied a ground when it shouldn't, or if the ignition system were faulty and applied a ground when it shouldn't, then there would be no spark. That could also happen if there were a short in the wiring. Once again, I'll be setting my meter to check for resistance, or in this case I'm going to use the continuity function, but again you can use resistance if that's what you've got. Now find the connector for the CDI. Again, mine is probably different than yours because I've replaced mine with weather pack connections. Disconnect the CDI, and you want the end that's coming from the harness, not the end that's going to the CDI. But you will need to know which one of the wires in the harness ends connects to, in my case, the white and black wire. The white wire with a black stripe that goes to the CDI, because that is the kill wire. That's the wire that allows you to disable the CDI. In my case, that is the center wire here. So I'm going to go ahead and connect one of my probes to the metal section of that center wire. And then the other probe needs to go to a good ground source. In this case, I'm just going to use the battery terminal, the negative battery terminal. You can already hear that my continuity indicator is going off. It's beeping to tell me there's continuity. That's what should happen when the key is off or the kill switch is in the off position or the kill position. Since this is ground to kill, what should happen when my kill switch is in the run position and then I turn the key on is that you'll hear that beeping stop, meaning there's no continuity, there's not a ground being applied. And it stopped. So in my case, that means I should have spark based on that. This is not disabling the CDI with a ground, because right at the terminal for the CDI, the connection for the CDI, I don't have a ground when my kill switch is in the on position or run position and my ignition switch is in the run position. Again, to retest, what I can do is turn this back off and I should hear that it beeps again. I'll turn it back on and then I can check the kill switch. I'm going to turn that to kill and I should hear that it beeps again. And it should stop when I turn it to the run position. In case you don't have a continuity checker and you're just looking at resistance readings, this is what I'm seeing when I've got the key off and the kill switch set to the kill position or off position. Now if I turn both of those to the on or run positions, then you can see I have no connection, no continuity there. That's what should happen if you have a ground to kill ignition system. So again, I'll go ahead and turn those to the kill settings. And you can see I've got a ground there again. If you go through the testing the way I showed you and you check each switch individually while you're watching the meter or listening to it, you may find that one or the other of these is faulty. You should be able to see which one based on which one you're switching at the time. If something doesn't seem to be working, you can go ahead and check the connections to either the ignition switch or the kill switch, whatever. And then you can also do the continuity checks directly on the ignition switch or the kill switch to see if they are faulty and replace if needed. If you're seeing a ground on the system when you shouldn't have a ground on the system, a short is another possibility. So what could be happening if you check the wire itself, go down the line and see if it's chafed anywhere, being pinched anywhere, or anything like that where it could possibly connect to a ground when you don't want it to. So it could be squeezed up against the ground by a bolt or just damaged wiring. At this point, I've checked basically everything that I can easily check in the ignition system. Starting with when I first broke down, I looked it over, I made sure none of the connections were loose or broken, disconnected. Then as you've seen, I checked the stator output, I checked the ignition coil, the wire, the cap. I did actually replace the spark plug while I was broken down, even though that's not a part of any of my testing. It's a good thing to do as one of the first steps, especially with a two-stroke that fouls plugs a lot. And then you've seen that I also checked for any kind of ground being applied to kill the signal to the CDI. And everything that I can check looks okay. So the next step for me is going to be to order a replacement CDI and see if I get spark then. I ordered this replacement CDI from scootertuning.ca yesterday, and it's here already. I did upgrade my shipping, but it cost me less than $15 to have UPS Express Saver and have it show up overnight. So I'm really impressed with that. Definitely check those guys out. As I've told you before in the videos, they helped me out a bit with a discount, but legitimately honest review, I got this thing overnight, so I'm ready to get back to testing already thanks to the guys at scootertuning.ca. I imagine for most of you this would be very simple plug and play. You would unplug the old CDI, plug the new one in its place, and see if it works. For me, since I have switched over to these weather pack connectors, they're clearly different than what comes on there, so I do have to switch that over, that way I can connect it to the scooter. That's all ready to go now, so I'm just going to plug it in. And then I can see if I've got spark now. It had spark. I even opened it up to a larger gap, and it still sparked fine. So I'm going to go ahead and put the spark plug cap on. I've got a lot of wires to tie up and such, but before I tie anything up, I'm going to take this thing off of the workbench, and I want to make sure that it actually starts. I've kicked and kicked, and the only thing I got out of it was a workout. The scooter won't start. I've tried all the usual stuff like using the choke, not using the choke, holding the throttle open, leaving it closed, working the throttle while you kick it over, all of that kind of thing just to make sure it's not a really simple mixture issue. I've taken the spark plug out to make sure it wasn't flooded. While it was out, I actually checked spark on the spark plug again just to be certain. Then I changed the spark plug to be 100% sure that there was no issue with that spark plug. Still nothing. I've tried adding some fuel to the system. That didn't get me anywhere. So I'm not sure exactly what's going on. I'm still suspicious of compression or maybe even something like a reed valve. But that will have to be for another video. I'm going to wrap this one up here because at least I did go from having a no spark issue to now having spark again. So I have, I believe, successfully troubleshooted that one. And I'm hoping that this video can help other people with racing ignitions, especially this MVT ignition, if they have their own no spark issues. So if you've enjoyed this video or learned something, please give it a like. Don't forget to subscribe for more, and thank you for watching.